What is wrong with Norton's dome? Is it unphysical? Improperly idealized? Bad math, or just bad physics? Up and Atom recently posted a video about Norton's dome, a mystical object that can allegedly break determinism in Newtonian physics. If you haven't seen that video or aren't familiar with the dome, check that out first and come back so I can explain where it all goes wrong. Also, Up and Atom has great content, so check them out.
Later.
Ooh, great, you came back. This is Norton's dome. Note that r is defined along the surface of the dome, not the Cartesian coordinate. That will impact our equation of motion. Here's how Norton did it. The force, and therefore the acceleration, always acts tangentially to the dome. But something goes wrong when r is bigger than 1. Do you see it? The acceleration would be bigger than gravity, which makes no sense, of course, if gravity is the only force acting on the mass. That's strike one. Now, the shape of the dome effectively limits the domain, which you can see when you plot the actual shape. I'll leave links in the description if you want to see my sources for the math. If we plot the dome in Cartesian coordinates, we see that when r is 1, the slope is vertical, and thus the acceleration should equal gravity. If the point mass follows the surface to this point, continuing tangentially, then it must be falling straight down. But then I took a look at the equations of motion in Cartesian coordinates. Notice the x-coordinate plot just stops when it gets to the end of the dome. Now look at the derivative, the x-velocity, and then the acceleration in x. It goes negative. This means that as the mass travels along the surface, the force increases, then levels off, and after a certain point, the mass must decelerate in the x direction, which only happens if a force is applied this way, which can't happen. The force comes only from gravity and the reaction force normal to the dome. That's strike two. So at least from this point on, without an outer dome to create centripetal acceleration, the mass will separate from the surface, and the x acceleration will just drop to zero. So in order for this to be physical, the equation of motion needs its domain limited. So let's cut the dome off here and see what happens. When the mass separates, it has some initial vertical and horizontal velocity, and then gravity takes over, giving us a parabolic trajectory. In Newtonian physics, everything is time reversible, right? So we could, in theory, chuck the mass up from below along this trajectory, and it will then follow the dome to the top and come to rest. If the dome were not present, it would only continue along the parabola and then fall back down. If you consider the conservation of energy, the vertical kinetic energy will only carry the ball to this height at the top of the parabola, and then the shape of the dome turns the horizontal velocity into the remaining needed potential energy to get to the top. And the math does check out here. To make the full story, we need two domain-limited equations of motion, the parabola and the dome. But there is a discontinuity when we change from one to the other, which we can attribute to the sudden presence of the dome. In other words, the discontinuity is physical. But do we even really care what happens down here? Now, the interesting bit of this problem is at the top of the dome. A similar discontinuity exists at the top in the case of our alleged non-deterministic motion. The mass sits at zero with no acceleration, no speed, but just before it could spontaneously move, there has to be a snap. If speed is the first derivative, acceleration is the second derivative, then the third derivative is called jerk, and the fourth called snap, or jounce. In the continuous solution, there is a constant snap applied, which is due to the shape of the dome, or rather how it changes over the length. When the mass gets to the top, it's no longer feeling that shape of the dome, just like when it separates, and so the snap goes to zero, as if the rest of the dome just disappeared at that instant. This is a physical discontinuity. But if the mass starts at the top, it's not feeling the rest of the dome, and it never does. You can take it away, replace it, scale it, but nothing ever initiates the snap. The ball sits at the top with no acceleration, no jerk, and no snap, so it never moves, just like Newton says in his first law of motion. Without snap, there is no jerk. Without jerk, no acceleration. Without acceleration, no movement, spontaneous or otherwise. Now, Norton tried to mathematically introduce a snap at time t equals t, but it is not physical. It isn't even well defined at time 0, which Norton admits, but then he argues that Newton still allows it. But why would he if nothing causes it to exist? There may be multiple solutions when considering only the second derivative, but without the third and higher, the problem is merely underconstrained. Just like in engineering, when you have a statically indeterminate system, you just need more equations and information about the state of the system in order to solve the problem. Norton even mentions this example in his paper, but somehow waves it away. And that's strike 3. So, my assessment is that the problem as defined is unphysical. Just because you have an equation doesn't mean it matches something physical. Physics cares about math, but you have to get the math right, including the domain and all physical conditions. Thanks for watching, and don't forget to subscribe.